That's going to be my new intro from now on. Welcome to Solving Stuff with Sosa. I think it's episode 3. Um, and we are going to be doing a circuit analysis workshop. This is part 1, where we are going to be doing circuit analysis using the mesh analysis method. Mesh analysis. So, let's get to it. Okay, so we are going to be looking at this circuit. This circuit has 3 resistors, a 2 ohm resistor, a 20 ohm resistor, and a 3 ohm resistor. It's got 3 power sources, a 12 volt power supply, and 2 current supplies, a 6 amp and an 8 amp. And what we want to find in this circuit is the power that is absorbed by the 20 ohm resistor. Okay, so we are going to begin doing a mesh analysis of this circuit. So before we do that, let's remember what a mesh is. So what is a mesh? To remember what a mesh is, let's remember what a loop is. So what is a loop? A loop is a continuous path across the circuit where current can flow and where none of the elements or components within that path are repeated. Now, what is a mesh? A mesh is a loop that does not contain any additional loops within it. Now we are going to identify the meshes in this circuit. Meshes. That's a tough word to say at this hour of the morning or the afternoon. Okay, let's get to it. So we are going to identify the meshes in this circuit. So we've got mesh 1 here to the left, we've got mesh 2 here in the middle, and we've got mesh 3 here on the right. Now, what we're also going to identify in the circuit are the nodes. Now, what is a node? A node is going to be a point in the circuit where elements join or components join at that point, and so branches are created. And when these branches are created, current is going to be divided throughout these branches. So these are going to be the nodes in the circuit. So let's identify the nodes. We're going to have one node up here that's going to be called node A. Then we're going to have another node that's called node B, and we're going to have another node here on the bottom that's going to be called node C. Okay, now once we've identified the meshes and the nodes, let's start to set up or identify or establish currents that are going to be going through the meshes. So in mesh number 1, we're going to have a current that I'm going to call I1, and that's going to go clockwise. In mesh 2, I'm going to have a current that's going to be called I2 that I'm going to say is going to go counterclockwise. And in mesh 3, I'm going to have a current called I3 that's going to go clockwise. Now, setting up these currents in either clockwise or counterclockwise, it doesn't really matter. Remember that in the end, when we do the calculations, we are going to get positive or negative signs. If we get the current with a positive sign, it means that we set the direction correctly. If we get them with a negative sign, that only means that the current actually goes in the other direction. And so now that we've established our meshes, our nodes, and our currents, we're going to start to analyze each of these. So let's start off with mesh number 1. In mesh number 1, we're going to be applying Kirchhoff's voltage law. And so if we go around the mesh, we are going to find that we have a voltage that goes from A to C, okay, that I'm going to call VAC. And there is going to be also a voltage in the 2 ohm resistor. Now the sum of these 2 voltages has to be equal to 0 according to Kirchhoff's voltage law. Now in mesh number 2, we have a jumble of things here. So we've got a voltage that is going from B to C, okay? And we've got also a voltage that's the power supply. And if you notice how the current is going, the current is entering the negative of the power supply. Then we've got the current that's flowing through the 20 ohm resistor. That's going to be I2 multiplied by the resistance. And lastly, we've got voltage AC. In the third mesh, we've got a voltage, which is voltage BC, and then we've got a current, which is 3 ohms multiplied by I3. Okay, and these also have to be equal to 0. Now, you might notice or might be a bit confused with regards to how we establish the signs for the voltages. Well, it's actually very simple. For voltage AC, if you notice, current I1 is going in the same direction as the 6 amp current that's going here. So since it's going in the same direction, I'm going to say that it's positive. The same thing applies with current I2 in mesh 2. It's going in the same direction, so that's why voltage BC, we're saying it's positive, and the same thing happens with voltage BC in mesh number 3. And so these 3 expressions that we have here, it's basically applying Kirchhoff's voltage law to each of the meshes. You thought you were going to escape my funky writing, but you are not. I'm still going to be doing my funky writing with the mouse. So this is applying Kirchhoff's voltage law. Now let's look at the nodes. If we look at node A, in node A we've got 2 currents that are coming in, I1 and I2, and we've got 1 current that's coming out, which is the 6 amp current. And so this expression represents what's happening in node A. In node B, we've got 1 current that's coming in, which is the 8 amp current, and 2 currents that are coming out, which is the I2 and I3. And so this represents node B. In node C, just for the heck of it, let's do node C. There's again a jumble of things. What currents are going into node C? 6 amps, and I3 is also going into node C. 8 amps are going out, and I1 is also going out of node C. Now, you might be asking, what's happening here in the middle? Actually, these 2 points that we have here are exactly the same points. So these 2 points here are the same. Both of them are node C, okay? Both of them are node C. And so basically what we're doing here is that we are applying Kirchhoff's current law. See, you're still getting my funky writing. And so now applying Kirchhoff's voltage law and Kirchhoff's current law, we now have a series of expressions that represents what's happening in the circuit. Okay, let's see what we can do with these. Ooh, this is the ghost of Sosa. Ooh. Nah, just kidding. I'm still here, but I've turned off my camera because I'm going to need all of the canvas to work out the rest of the solution here, and I don't want my big face to be interrupting anything. So my camera is going to be off, but I'm still here. So now that we've established the mathematical expressions that represents what's happening in the circuit, what we're going to be doing now is trying to reorganize these so we can work with them. And so for mesh 1, what we're going to do is represent that expression with regards to VAC and current 1. So VAC is going to be equal to minus 2I1, and we're going to call that equation 1. For mesh 3, we're going to grab that equation and we're going to represent that with regards to VBC and I3. So VBC is going to be minus 3I3, and we're going to call that equation 2. Now for mesh 2, we've got this jumble of elements here. So what we're going to do first is we are going to substitute equation 1 here, and we're going to substitute equation 2 here. Okay? And what we're going to obtain is a representation of the equation. I'm going to do this. I'm going to draw this better, actually. I didn't like the way that came out. So what I'm going to do is this. This is much better. We're going to grab equation 1 and put it there, and we're going to grab equation 2 and put it here. That's much better. I told you you weren't going to be missing my funky drawing and writing. And so now we've got an expression that only has the currents, I1, I2, and I3, and we're going to reorganize that one. And so we're going to have an equation that we're going to call equation 3 that's got the three currents, 2I1 minus 20I2 plus 3I3 minus equals minus 12. We're going to call that equation 3. Now from the nodes, we had I1 plus I2 equals 6. We're going to leave that as it is and call it equation 4. For node 2, we had 8 amps equals I2 plus I3. We're just going to flip that one, and that's going to be I2 plus I3 equals 8. We're going to call that equation 5. For node C, just because we've got that expression there, we're going to reorganize that one. So it's going to be I1 minus I3 equals minus 2. That's going to be equation 6. Now, we've got three variables, I1, I2, and I3. And so we need three equations. We've got 6. We don't need too many, all of these equations. So we only need 3 to create a 3 by 3 system of equations for the three variables that we're looking for. So we're going to grab equation 3, we're going to grab equation 4, and we're going to grab equation 5. By the way, we could have also used equation 6, or actually any combination of equations 4, 5, and 6 for the last two equations. We're using equation 3 because of the mesh equations. That's the only one that has all of the currents. But we could have used equation 6 also for any of the last two. And so we need to solve this system of equations. I'm not going to do that here. Why am I not going to do that here? Because that's maths, and you guys should know maths if you're taking this workshop. So I've included a very practical, nifty web page there that can help you solve systems of equations. It's still my ghost. My camera is still off because I'm going to need all the canvas here also, and we've got a special guest, and I don't want my big face interrupting that. So now that we've got the three equations and we've solved them however way we want to solve them, but we could have used the web page that I provided, we're going to find the three currents, I1, I2, and I3, which the values you can see there. Now, remember that what we're looking for is the power that's dissipated or absorbed in the 20 ohm resistor, okay? So really we don't need to solve everything for the circuit. We just need the values that are going to give us enough information to calculate that power. And so we've already got the current here going through I2, which is 1.92 amps. And with these 1.92 amps, we can, and the 20 ohms of the resistor, we can calculate the voltage going through the resistor, which is 38.4 volts. And we know that power is voltage multiplied by current. So the power in the 20 ohm resistor is going to be the 38.4 volts multiplied by the 1.92 amps, and that is going to give us 73.728 watts, which is the power that's being absorbed by the resistor. And guess what? This is equal to the answer of the problem, rounded up, of course. And so, yeah, that makes James Hetfield happy. So he's screaming in happiness, yeah. So this is the procedure to solve this circuit, what they're asking us to find, which is the power absorbed by the 20 ohm resistor using mesh analysis. Hi there, my camera's back on. I am back. You are looking at me now. You're not listening to the ghost of Sosa. So I hope you enjoyed and learned something today in this video where we explained how to solve a circuit using mesh analysis. So solving stuff with Sosa. Let's make this viral. See ya.